So we're continuing our exploration of quadratic equations, and this skill is going to be converting equations from standard form to vertex form. And the question comes up, what in the heck does that mean? Well, you've seen equations in standard form and vertex form. Let me quickly remind you, standard form always looks like this. It's got the thing with the squared term first. Might have a positive or a negative number out here. It might be plus, it might be minus. A thing with just x, and then plus or minus a number of some type here. So it always has the squared term first, then the linear term, and then the constant term. So that is standard form. Okay. When you've seen vertex form, it always looks like this. Some number is out front. In parentheses, there's x minus or x plus, never x squared, just x minus or plus some number. The thing in parentheses is always squared, and then there's usually some number out the back. Maybe it's minus something or plus something. It might be 0, but usually we get some number. And so this is in vertex form. And the question comes up before we spend a bunch of time trying to learn to convert from standard form to vertex form. We've already done vertex to standard in a previous video. Before we do that, I want to spend some time looking at what in the world does this mean anyway. So to do that, I want to go over to the Desmos graphing calculator. Okay, so I've got Desmos going here, and I'm going to type in equations in vertex form and have you see some things about them. So let me just get one typed in here. Okay, so here's what I've got going. There's a generic equation not a generic, an equation in vertex form. And to illustrate what's happening, I want to point out some things. I'm just going to type in the most basic quadratic equation you could ever have in your life. Okay, just y equals x squared. I'm going to move that to the top, and I'm going to put that in black so that that's kind of our basic one. Okay. And then I want you to notice some things about these. Okay. First of all, notice the y equals x squared. That was centered right here at 0, 0. It basically came down here, bounced off the x-axis at 0, and then went back up. And I want you to think about it this way. If you were trying to get the lowest possible number out of this, what would you put in? Well, anytime you square a number, it's going to become positive. So to get the lowest possible number, you'd be looking to get 0. And the only way you could get 0 out of this would be if you put in a 0 for x and then square it. Well, this one, I'm going to ask the question, what would you put into this one so that you'd get 0 in here? Okay, and then minus 2 would make it just a little bit smaller. So you'd have to put a negative 3 in here to make this part right here 0. Okay, and then once you got 0, when you multiplied it by 2, you'd still get 0, and then you'd subtract 2 and you get negative 2. So what's happening here is getting negative 3, putting negative 3 in here basically bottoms this thing out. And that's telling you this right here. When you put negative 3 in here, you get the lowest possible number. Okay? So here's what happens. When you type in x plus 3 in here, it shifts the equation 3 spaces left because negative 3 is the number you'd put in there to make it the lowest possible value. If I change this to 5, now it's shifted 5 to the left. If I make this a positive or a minus 5, now it's shifted 5 to the right. In other words, positive 5 is what you have to put in here to make this thing bottom out and become the lowest possible thing you can get here. So when you multiply it by 2 and then subtract 2, you get the lowest possible number. Okay, so there's some things you can realize about this. Let me type a new one in here. Y equals 3x minus 1 squared plus 3, let's say. And here's what you can notice. This one looks like it got shifted 1 to the right and 3 up. Well, you can tell that right here. To get the lowest possible value here, you'd have to type in a 1 for x. Okay, because 1 minus 1 to get you 0. Okay, and then 0 squared, of course, is 0. So that shifted it 1 to the right, and then the plus 3 right here shifted it 3 up. The 3 right here and the 2 right there have to do with how stretched this thing became. To illustrate that, let me turn these off for a second, and I'm going to type in a new one: y equals ax squared, right there, and then it's going to ask me if I want a slider for a, and I'm going to say yes. Okay, and here's what's going to happen. Right now, the blue equation is right on top of the black one, so you can't even see the black one back there. But if I move this to 2, now, actually I guess it's purple. The purple equation, the purple graph, has been stretched upward. Okay, the way I like to look at it is this. If you zoom in right in here, this one, the black one, you went over 1 and it only went up 1. But with the purple one, you went over 1 and it went up 2. So this 2 right here kind of tells me how much it jumps up on the first one there. So if I make that a 3, it stretches it up even more. Okay, there we go. Try to get it 3 if I can. Yep. So now it's stretched up to 3. So this number out in front here stretches it. So let me turn those things off here. And I'm going to go back and look at these. And I'm going to have you notice that the 2 and 3 basically stretch these things. And then the stuff that was important for moving it left and right was right in here. That moves it left or right depending on what you have inside here. And this moves it up or down. Okay? So when I have some equation that I type in here and I go y equals 5x plus 3 squared, whoops, screwed up on that, plus 3, okay, squared, and then let's go minus 7. Okay, you can tell, even if you didn't see the graph over here, you could see, since you had to put a negative 3 in here to bottom this thing out, that it got shifted 3 to the left. The minus 7 moved it down 7, so here it is, back 3 and down 7, and then the 5 stretched it. Well, what is this vertex form business? Well, this point right here, the bottom of the graph, the bottom of the graph, is called the vertex. So the reason we call this vertex form is you can tell what the vertex is just reading the equation. If I had some other equation up here, y equals 2x squared minus 4x plus 5, you can't tell where the vertex is on that one unless you look at the graph. There it is right there. So this is in vertex form because you can tell where the vertex is just looking at the equation. Okay, so I wanted you to see that because we're going to use that idea to convert equations from standard form to vertex form. Let's go back to here. Okay, so let's get an equation that we want to convert from standard form to vertex form. Okay, I've got those equations, these equations written on the screen here, and our job is going to be to convert each of them to vertex form. Well, to get you started on that, and this is not how we're going to always do them, but I want you to observe some things first. I've got those equations typed in here into Desmos in the same order, green, purple, blue, and so I want to look at these things separately. Okay. So here's the green one, and I noticed looking at the graph that it's got a vertex right here at positive 3 and then 5. So what I'm going to do is say, look, you know what? Since I can tell what the vertex is, I can get the equation written. Okay? Because I know, let's start out with the y equals. I know that in order for that thing to be shifted right 3, I have to have an x minus 3 inside the parentheses. Now I don't have it squared yet, so it looks like a line. But as soon as I square that, okay, now it's x minus 3 squared. And then since it also shifted 5 up, we'll just put a plus 5 there. And you'll notice they match up perfectly. Now, you can't see the green one anymore because I've got the equation written there. So one option is for me to just look at the graph of it and then figure it out from there. Okay. Let's look at the next one. Let me turn that one off, turn this one off, and turn that one on. Okay. that one has been shifted, looks like 4 to the left and then 6 down. So I can get its equation pretty easily. I can say y equals, let's see, 4 to the left. I'm going to have to have an x plus 4 in there, okay, to go 4 left. Okay, again, you can think of it this way. In order to bottom this thing out, in order to make that thing as low as possible, you have to put a negative 4 in for x to make this become 0. Okay, so there's the equation. It just needs to go down 6 now because the vertex is at negative 4, negative 6. So we'll just put in negative 6 there, and sure enough, we've gone right on top of it. So we've been able to look at the graph on that thing and tell what's going on. Okay, so let me look at one more and turn that off, and turn this one on. And oh, good grief, where's that go? Well, let's move it up a little bit. It looks like that one was shifted, 6 to the right, okay, and then 12 down. So in order to get a shift to the right, y equals, and then inside here, to get a shift to the right, I'm going to have x minus 6, and then, of course, squared. Okay. Oops. Fix that. Put the squared outside. There you go. Okay. So there's the purple equation up there, but now it also has to go down 12. So we'll just type a minus 12 in here, and sure enough, we managed to hit it. Well, that's great, except it'd be nice if we didn't have to keep coming over here and graphing the thing and then looking to see where it is, because what if this went to the right 100 and then down 300 or something weird like that? That'd be pretty dang difficult. So I want you to notice something. In class, we would spend more time observing this pattern, but I don't have the time during the video to really have you do that. So I want you to notice something here. Let me turn all these off and then go back to the first one. Okay, so there it was right there, and then notice that that we've got the thing exactly on top of each other. This is the vertex form of that one when it's in standard form. And what I want you to notice to start out with is this. See this number right here? Okay, I want you to tell me how that is related to this number right there. Okay, so in class I would do this. I would make a copy of that. In fact, I think I'll do that right here. Let me pause the video. Okay, so I've got that Desmos graph copied into my drawing software here, and what I would have you notice is this. This number right here is related to that number. Let me just highlight the number there. Okay. And this number right here, the horizontal shift for that one, is related to that number. And this number here is related to that number. Okay? And I asked people, what's the pattern? And what they noticed pretty quickly was that whatever this number is, if you cut it in half, you get that one. Okay? Let me say it again. Whatever this number is here, if you cut it in half, you get that one. And different color here. Whatever that number is, if you cut it in half, you get that one. So what we start to figure out is, hey, I could probably get started on one of these things without even having to graph the thing. Okay? So at that point, I pull up a new equation and I say, let's look at the top one for now. With this one right there being 14, we know that in the parentheses, we're going to have an x plus 7. Okay? So we've already gotten a start on this equation by knowing that, let's see, that was a plus in there. Yep, okay. That because that's positive 14, this has to be positive 7. Okay? Let's look back at those other ones here. The number here was half of that one. The number here was half of that one. The number here was half of that one. So the number in the parentheses is half of the number in front of the x. Well, that raises the question, that's nice, what's the number that goes out here? Okay. Well, remember what I'm asking. I'm asking, what's the y coordinate of the vertex? This number right here is how far it's been shifted up. So in reality, what we're asking is, hey, where's the vertex? And we've already answered part of that question. We know that because the thing is shifted 7 to the left, the vertex is at -7, something. Okay, I don't know what the y-coordinate is here, but I do know this. Whatever number I get right here is the same number that goes here, because each of these describe how far up and down this graph is shifted. So here's what I'm going to do. I'm going to say, look, if I want a y-coordinate here, then I need an x-coordinate. In other words, if I look up here at this original formula right here, the original formula for y-coordinates is right here, and it's telling me how to get y-coordinates if I know x-coordinates. Well, I know an x-coordinate and I want a y-coordinate. So what I'm going to do is put -7 in there and -7 in there and calculate a y-coordinate. You can just grab a calculator and square -7. Remember, when you square -7 on a calculator, you better get +49, not -49. If you get negative, you're typing in the calculator wrong. So square -7, you'll get 49. Add on to that 14 times -7, and then add 1, and you'll get the y-coordinate. Okay? So grab a calculator and try it out. Let me get one here. I'm going to type in off screen. Here's -7 squared plus 14 times -7. I'm just typing this on the calculator. Plus 1. Press equals, and I get -48. Okay, so that's the number that goes right in here. -48. Okay. So when they ask you what's this number, or what's this equation in vertex form, you're just going to write y equals x plus 7 squared minus 48. Now we'll look later about what happens if to get a number right here. I'll give you a hint right now. If there's a number right here, that means there was the same number right there. Right now we don't have any numbers there, so we won't have a number right here. Okay. So let's look at another one. I'm kind of running out of room on that equation, so let me just go to a new one over here, and let's take a look at that one. Okay. I could graph the thing, or I could say, you know what? I do know that whatever number goes right here is half of that one. Well, half of +2 is +1, okay, squared, okay, because it's got to have a squared in there. And then the last question is, what goes out here? And again, I can figure out what goes out here by simply writing the vertex. I know the vertex is at -1. How do I know that? Well, this tells me that -1 is what I have to put in here to get this thing to be the lowest possible number, to bottom this thing out. Okay, so -1 goes right here, so it shifts to the left 1. Okay, and now I need to find the y-coordinate. And to find the y-coordinate, I'll just put -1 in for x in both places. So -1 squared plus 2 times -1 plus 50, and calculate what it is. I'll pause the video and get it. Okay, and I get 49. So what that tells me is that the vertex is at -1, 49, okay, which means I need to have plus 49 right here. Well, how's this stuff going to look? I like to use Delta Math for having students do homework. So I want to look at one of these right here in Delta Math. Here's a new one. The equation is this, and it asks me for two things. It wants me to put the thing in vertex form right here, okay, and it wants me to actually write the vertex. So let's make a copy of that so we can take a look at it. Go to a new page. Just copy this. And now we're looking at the thing. And the great thing is we know already that the equation starts this way. Inside here I need a -1, and then I need it squared. How did I know that was -1? Because here is always half of that one. Okay? And then of course it's squared. Well, I do need to know what goes out the back door here, plus or minus something else. So what I'm going to do is say, I know the vertex is at 1 comma something. And I knew it was at 1 comma something because this means it's shifted to the right 1, and which means the vertex, the bottom of the thing, is at 1 comma something. Let's find out what the something is. To do that, I'll put 1 in for x in both places and calculate what y is. So I have the y coordinate of the vertex. So y equals 1 squared minus 2 times 1 plus 37. So 1 squared is 1, minus 2 makes it negative 1, and then plus 37 is 36. So I get 36 for the y coordinate, which means it's shifted up 36. So I'm going to memorize these two things here. The equation is x minus 1 squared plus 36, and the vertex is 136. So let's go back to Desmos. Okay, it was x minus 1, don't forget the squared outside the parentheses, plus 36, and the vertex was at 1 comma 36. Let's submit our answer and see what we get. Okay, there we go, we got it right. Let's look at a new problem. So this one, we'll copy that. Oh, shoot. I'll take this and put it over here so I can work with it. Okay. We can already get started pretty nicely because we know that it starts with y equals something squared, and the number right here has to be half of that one, so plus 6. Okay. I just need to know what goes out the back side. Well, I do know that the x-coordinate of the vertex is at negative 6, okay, because negative 6 is what I have to put in to make this 0, or another way to put it is x plus 6 means it's going to shift left 6. So it's going to be left 6 right here, and then let's go figure out what the y-coordinate is by putting negative 6 in for x in both places. So negative 6 squared plus 12 times negative 6 plus 35. And you can calculate all this stuff here. This is going to be 36. This is going to be minus 72, and then plus 35. 36 minus 72 is negative 36 plus 35. It's going to give you negative 1. So I know the x-coordinate is negative 6. The y-coordinate is negative 1, which means it's shifted down 1. So your equation is going to be x plus 6 squared minus 1. And then the vertex is going to be negative 6, negative 1. X plus 6 squared minus 1. And then the vertex, vertex is negative 6, negative 1. Okay, we got it right. So you've seen how to do those. The question comes up, well, what if there's a number out in front of here? Like if it's a 2x squared minus 12x plus 5 or something like that. What happens about that? Well, I think what I'm going to do is wait on that for another video since it's gotten pretty long. We'll just do some practice on this one.